Hello, good morning, everyone. This is day 4 of Data Science Bootcamp. Today, we will be learning what NumPy is. We will be continuing from the previous lecture, and today we will be understanding the further functionalities of NumPy. Okay, Nishant, Krish, David, did you guys go through the previous lecture? Okay, cool.
Yeah.
Yes, sir.
Okay, so what we will learn today, there are certain functionalities we learned in the previous lecture that was like creating array, creating full arrays, creating multi-dimensional array functionality, how we can do conditional uh, splitting. Then there was you can pass an array outside of NumPy array, and then it will return certain sections, right? All of you guys are familiar with this. So all of this may look small. The reason we use NumPy is it is fast and efficient. That's the reason. You can do most of the functionalities using core Python. You may have to write lengthier code, but using NumPy, you have to write short and precise code. And also it is way faster than Python is because behind the scenes, it is built in such a way that it is more efficient to handle large amounts of data. Cool. Okay. Okay, so I'll start with today. This will be multi-dimensional indexing and access. Like what is multi-dimensional indexing and what are accesses in a NumPy array. Okay, what we are doing, we are importing a NumPy. We are creating an array. Now this is what?
Can you zoom?
Yeah, sure. Is it better?
Yes.
Okay. So let's run this. This is an array. Can anybody tell me what is the shape of this array?
3 cross 3.
3
So
by
3
3.
cross 3 array, and it is a 2D array because there's an array inside of an array. If you understand. Okay. Now there are certain function if you want to run on axis one. Now what are accesses in NumPy? Okay. Just give me a minute. Yeah. So what we are going to do, we are going to run a sum function on the array on axis one. Now axis one is column. Okay. I'll pull out the documentation. Axis in NumPy. I'll pull out the documentation. Okay. It's not the official one, madam. Always go to the official documentation. Okay. In this case, what we have an array. We want to do a sum on axis of 1. So when it is axis of 1, what we are doing sum of the columns. Okay, let's understand. So if it is understanding, okay, is a powerful library working, what are axes? Imagine a NumPy array is a multidimensional grid. Axes are simply the direction you want to move along the grid. Think of them like X, Y, Z coordinate in a 3D space. Get it? Decoding axis is equal to X. The axis argument in NumPy function specify which axis to perform the operation along. Here is it how it translates the array dimension. In a 1D array, axis is equal to 0. The only axis available is the operation will be across all the elements. So if it is a 1D array, the axis is if axis is set to 0, there can only be one axis that will be axis 0, and all the operations would be performed on axis 0. So let me show you. This is a 2D array. Let's create a 1D array. Let's create a 1D array. Okay, 1D array is equal to 1, 2, 3. What we are going to do? Sum is equal to np dot sum 1D array. Now, dot sum, yeah, sum is equal to np dot sum. Okay, current sum. It is 6. Now, if I do a 2D, if I make it a 2D array, this will not. This will also work. Let me show you. We already have a 2D array. So what we are going to do? We are going to utilize that. We are going to utilize that, which is array. Okay. It's 45. It is doing sum of all the elements. Now what I want to do, I want to sum of axis 0. Okay. Now axis 0 is 12, 15, 18. Now if you look at it, axis 0 is the column. Yeah, that's correct. Numbered left to left. In a two-dimensional, the element of axis of 0 are rows and element of axis 1 are columns. So these are rows. So if I do a sum, then these are all the rows. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is some, and it is written in 12, it is written in 4, 5, 6. In an array, axis of 0. Okay, if I do an axis of 1, it will be 6. Okay, 1, 3, 6, 4, 5, 6, and 7, 8, 9. Okay, now if I want to do axis of 0, this is sum of all the rows. So 1, 4, 7. You see, it is 12, 2, 5, 8. It is 15, 3, 6, 9. It is 18. Now I want to do sum of column. I did for 1, right? Now this is 1, 2, 3 is 6, 4, 5, 6 is 15, 7, 8, 9 is 24. Get it? Any questions on axis? All right. Okay. So we will just go through the this documentation. Now in 2D array, x is equal to 0 operates along the rows, that is vertically. As I explained here, if x is equal to 0, it will operate along the row, that is vertically. And it is 12. 1, 4, 3, 2, 5, 8, 3, 6, 9. And this one will work on horizontal. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's check here. This one. Okay, in a 3D array, operates along the depth of the outermost dimension. Maybe we have certain example. Let's check it out here. Okay, we already check on axis one. Okay, we get the answer. Now I want to now this how do you access the element of a 2D array? Okay, array of 0, array of 1. Okay, I want to get the second element of the array 0. So array of 0 of 1 is 2, as you can see, and this is how you get it. Now I want to slice a 2D array. So this is how you can slice a 2D array. This is a certain thing you can't perform on Python, but NumPy gives all this functionality out of the box. You want to split from 0 to 2 and 1 to 3. And this is what the result that you get. Okay, let's quickly go over it. We will, and you guys would be coding this afterwards, and then you will have more clarity. Okay. Now next we have a 3D array. Okay, np.array, we have a 3D array. This is three-dimensional array. What we have was a two-dimensional, now it is three-dimensional. Okay. Similarly, if you use a column, you get all the elements, like initial and the first element and the last element. When you just put a column, you get all the elements. This will only give the zero element, and this will give all the elements. So when you put a zero, it does not get you array of 3D. You want to make it a 3D array. You get 1, 2, 3, then you get 7, 8, 9. That's it. Nothing else. And you get the array. Okay. If you want to set an array to 0, okay, so all these elements will be set to 0. Get it? The more you practice, the more you'll understand, and keep using documentation. Whenever in doubt, just use documentation. Okay, let's quickly try to. So where did the screen go? Oh, okay. Okay, so I am putting the notebook here. Just quickly code it in your notebook, and if you have any doubt, let me know. Cool. Create a 2D array, then do sum, then get elements, then slicing and indexing, and then do the same for a 3D array. Should I scroll down?
Yeah.
Are we done? Oh, okay. Let me know when done. Okay. Is there any doubt regarding this, anywhere now since you have typed it out? There might be questions.
Can you explain a little bit of the 3D array, like how it works in 3 dimension?
How it works in okay.
Like, yeah.
So in 2D array, it is a 2 cross 2. I mean X cross Y matrix, right? In 3D, there will be like 3 dimension. So it will be X cross Y cross Z. So when you look at it, array dot 3D dot shape. Okay. How do we get a shape in NumPy? Anybody? Can anybody help me?
No curly braces. No.
And
Correct. It's not a function. Okay. 2, 2, 3. So the shape of is 2, 2, 3. 2 is the depth. 2 is the I think it's x axis and 3 is the y axis. So how it is? If you see, the depth is 3. There are 1, 2, and 3 elements. Can't visualize it properly with the name. I printed the same way. Okay, see, there are 3 brackets. Okay, 0, 1, 2. Okay, so there are 3 brackets, and then third depth, then you have element. So how do we access it? You need 3 level to access elements in this 3D array. Okay, so it has 3 axes. First is, let's say I want to get the first element. First I get inside. Now it is a 2D array. Array of 0, when I do it, it is a 2D array. Now when I go inside it, then I get the array element. Okay. Now it is a 1D array. Can you see it? It is a 1D array. Okay, I'll do it again so that you can visualize it better. This is a 2D array now. Get it? Now if I go inside it on the first element, this is a 1D array. And now if I want to get the element, I'll get 1. So this is 1. So this is on a 3 level. The depth of this array is 3. Get it? So that is 3D array. Usually, if you want to visualize certain coordinates on a 3D space, 3D array is something used. In my experience, I have not used an array more than 3D array in visualizing data, in manipulating data, in analyzing data. I haven't used more than 3D. Okay. And sometimes also certain functions, let's see this as we are using, this I don't really use a lot. It's something even I forget. So all of this can be helpful later. So that's it. Any questions on 3D array? Like you want to visualize it? That's it. No, right? You're good. Nishant, Devesh. Okay, cool. Shall we move ahead? Okay. Any doubt? Do let me know. I'll be happy to skip it. Okay. So next, what we have?
Sir,
Yes, Devesh.
so in the 18 and 19 line, we are what we are doing.
Sorry, come again.
18 and
In
19.
18,
18 and
19.
19. Line, what we are doing, how is it work?
Oh, okay. So it is a shortcut for indexing. Let's say if I want to get all the elements of zeroth index. Let's say if you're seeing, if I do array of zero, as you saw it here, if I do array of zero, I get all these elements. Can you see it? Okay. So what it is doing, array of zero of column, getting all the element of the first, getting all the element of seven, first element, and getting all the elements of seven inside the zero index, if you're getting it. So if I want to get all the elements, that is 1, 2 of 0, this is 0, and I want to be able to print all of them. Hmm. If I do array of 3D of, let's say, 0 of, sorry, 1 of 0, 1 of 0, that is 7, 8, 9. So all the elements which are on the 0 column, okay, will be sliced here. Did you get it?
Yes.
Okay, you see, 0 of 0 is this, 1 of 0 is this, and we are getting a new array which is these elements. Okay, every time you try to manipulate data, let's say if you have a certain filter, let's say if you want to get the first element, third element, something like that, over a column or anywhere, you should use Google or now ChatGPT, so that because there might be certain functions available, because NumPy gives you a lot of functionality out of the box. Even I may not be familiar, or many people may not be familiar, but when you have an idea, you have to utilize internet to get further things. Any other doubt? Any other questions? Anybody? No, right? Okay, let's move ahead. Um, I'll do. Okay, we'll do data types and NumPy now. Cool. Okay, now let's understand data type in NumPy. You guys are familiar with data types, right? Python has certain data type. Integer is a data type. Do we have floats in Python? Anybody? Do we have floats in Python? Nishant, Krish, Devesh. We do, right? I mean, all the data types are available in Python. It's just you don't declare it. You don't declare it as int. You don't declare it as float. Just assign a variable and that's it. Okay, what is it called? Anybody? Runtime declaration or complex thing? Okay, let's not go into Python detail. Okay, cool. Let's only stick to NumPy. Okay, here is a NumPy. We are creating an array. What is the array? It is a 1D array with certain elements. There are 4 elements. What is the data type of this element? Is integer 32, type 32. Okay, what I'll do 0. Let's check the data type of this element. It is float 64. Why is it float 64? Because a certain element is a float. Get it? That's why the whole data type of the NumPy array is mentioned. Now, if I do a string, oh, sorry, data type, what should be the data type? Anybody?
And U1, U for data structure, like
Wow, nice, cool. You have worked
U11.
with NumPy. U11, that's string data type. The reason being, NumPy, you can't have multiple sort of data type because it performs operations after over it. It is sum assign of operations or anybody. Let's do one thing. Let's do A and let's do a sum. Okay, while you're practicing this, you also do this. Maybe run certain command. Okay. Now add function did not look into the because U11 will not work. Okay, so this did not work. Maybe you can expect like, yeah, will it create a string of A4323? Means that also could be an expectation. So run certain functions. Once you run into trial and error, you will understand why there are error and all that, and you'll learn it in a better way. Okay, we have 23, we get the data type. Now, what we are doing, we are changing the type. In order to change the type, this is a function used, which is astype. Okay, that is as type. Okay, array to s type, I convert into float 64. Now it is array 23.0, I mean 4 point something, 3 point something, 23 point something, and so on. Now let's convert as an array to, let's do a float 32. Then the difference is it stores in 64-bit, it stores in 32-bit. Get it? In last lecture, we saw when we tried to convert a 64-bit to 34-bit, we got a negative answer because there was bit manipulation that happened behind the scene. Okay, we get array. This is of type 42. Now see what are the array to how many bytes it is taking with the 64. Usually, this is not something you would be using, maybe not very frequently, but these are good to know feature. Okay, then you see array of n bytes is also 64. Now, if the bytes, how come bytes are similar? If it is float 32, float 64, how come bytes are similar? But when you check on integer, the bytes are different. Okay, for 3 elements into 8 bytes each, which is 24. For 3 elements into 32 bytes, which is 12. Okay, let's quickly go through it. So in order to, if you, let's say there are small numbers and if you want to use less space, usually memory is not a concern. I worked with petabytes of data. Memory is not a lot of concern unless and until you are running on a local system. But these are good to know feature. Like if you want to use enter, if you want to use more precise, use 64. Let's say, and anyways by default it is type 32. If you want to change a data type, use a higher value data type. You want a better precision. Okay. Okay. If you, okay, maybe let's skip this part. I don't think it is that important. Or do you guys want to have it in your notebook?
No, no.
It's fine, right? Understanding data type, converting data type. Okay. Only remember to get a data type with this data type, to convert is you have to use as type. Once you use as type, it is converted. And the size value of different data types are different. Like 32 stores there, let's 64 stores more. Okay. That's it. Let's move to other lecture. Now we have few operations with NumPy. Okay, we will be understanding broadcasting. Okay, we already went through this in the first lecture, like why NumPy is slow and why, sorry, my bad, why NumPy is fast and Python is slower. We'll again go through it. Initially, we are using importing NumPy. Then we are creating an array. Array, this is a 1D array. What are we doing? We are getting power of all the elements. So if you run it, power of 1 is 1, 2 is 4, and 3 is 9, and so on. What we are doing here, as you can see, this is a certain operation that is permittable in NumPy, but it is not permittable in Python. You know, see, it uses vectorization. I have explained in the first class what vectorization is. When you run it on Python, let's say what we will do, there are no Python code. When you run it on Python, the code goes through a loop. Like if I want to do a similar operation with Python, what I'll do ey underscore array is equal to 1, 2, 3, 4, 5. If I want to get power, either I'll use list comprehension or I'll use a for loop. So I'll do result. Result is equal to I into, I think yeah, this should work, for I underscore I. It worked, right? Now if you are saying it is going through a loop, So that is one element at a time. But vectorization, it creates, I mean, it's not exactly threading, but it does not go through loop. It creates a vectorization. Think of it like that it does not iterate through each element over and over again. Get it? So that is the power of NumPy. Now, if I mean, in the previous lecture, I created an array of 1 million, of 1 million elements, and I showed the difference that I won't be doing it here. So let's just remove it. Okay. Then what I want to do, I want to add 10 to each element. So this is exactly how you do it. So these are the feature of Python. I want to 10 to all the elements. Okay, it was 1, it is 11, 4, it is 14, 9, 10 is 19, 6, 26, 35, and so on. Okay. Similarly, there's an array. This is 2D array, this is a 3D array. What I'll do, okay, this is a NumPy array. Sorry, this is a 2D array, this is a 1D array. Result array of 1 plus array of 2. Now what did we get? We got 2, 4, 6, which is 1 plus 1, 2 plus 2, 3 plus 2, 2, 4, 6. And it again added with this as well. 4, 5, 6, 1, 2, 3, which is 5, 7, 9. Okay. So this is one of the syntax. Let's say if you want to add, then all the elements, let's say it's a 1D array. What we'll do, we'll also create a 2D array. Let's see what happens. Okay. Will it even work? See, 1, 2, 3, 1, 2, 3, they come together and 4, 5, 6, 4, 5, 6. So NumPy intelligently understand, not intelligently, like whatever, it's not AI. So NumPy, this is how it does it. Let's say if it's 1D array, it will add to all the elements. If it is 2D array, it will add to only certain elements on the row level. So these are the matrix operation. Are you guys familiar with matrix operation on summation and multiplication? That's something you might have done in your college. So
Yeah.
those operations are easily achievable in NumPy. Now, what we'll do, let's create a 3D array. Okay? 7, 8, 9. Hmm. Yes, operands could not broadcast together with shape 2, 3, and 3. So these are the things, I mean, 2, 3, and 3, 3 cannot do a summation. Okay, so that comes under basic maths, not basic maths. I learned it in college. Get it right? Do a trial and error whenever you practice. Do a trial and error. That will help you understand the functionality. Okay. Similarly, what we'll do, we will calculate mean and standard deviation. Okay. There's an array. Okay. It's a 2D array. We will, in order to get mean on the axis of 0, which is, okay, calculating mean and standard for each feature on the column level, that is axis of 0, and standard deviation axis of 0. Okay. So when you do it, sorry. Okay. So these are the mathematical functions which are inbuilt in NumPy. In order to get mean, you get the mean. Okay, what we'll do, we have the data, we will get what is the mean. Okay. Mean of all the elements, which is 20, 30, 40. What I believe mean is sigma fi xi upon n. So sigma, that is 10, 15, 15 divided by n. So on a level, if I say it on axis of 0, 0 is on column. So 10, okay, 12, 13, which is 10, 30, 30, 60. 60 divided by 3, it's 20. Get it? And then we have 30, then we have 40. Okay, on a column, just a check. Okay, let's skip the verifying part. In order to do certain operations, we have to, there are operations available in NumPy. Okay, okay, that should be it. Cool. Okay, please put it in your notebook. I am sort of pacing the class now because I wanted to cover more topics. If you want me to go slower, do let me know. I'll do it in that way. Okay, this is the notebook. Please copy it down and let me know when done. I'll paste it so that we don't have to type it out. Do let me know if you need explanation.
Yeah, done.
Done, right? Mean, standard deviation, we are doing against column. All clear, right? Nishant, Krish, Devesh.
Yeah.
Okay, cool. We'll be moving on to the next lecture. Okay, there are certain mathematical functions. Okay. We just saw the mean function and the standard deviation function. Similarly, these are the mathematical functions that are available. Okay, of which mean you get the average, standard deviation you get the standard deviation. If you want to get the variance, it is bar. If you get the minimum value of the array, it is min. If you want to get the maximum value, it is max. If you want to compute sum of all the elements, that is sum. Get the product of all the element prod. Always remember, if there is a mathematical function which you want to perform, don't do it. Don't write the logic. Do a Google search. Check it out somewhere. There is a very high possibility it is out of the box. It is available out of the box in NumPy. If you want to get median, this is how you get median. Similarly, percentile. Okay. Minimum of the index value in an array. Okay. Let's say there are okay maximum of the return index of the maximum value in the array. Okay. This is something even I have to. We'll check it later. And correlation coefficient something I don't even remember. I believe unique returns unique elements. Difference of the okay compute the nth difference of an array. We'll check it together. Okay, linear space. Okay, creates an array of evenly spaced integer. Let's say 0, 10, 5, and it will give from 0 to 10. It will create two elements, I think, 5 and 10. So with a difference of 5. np.log nature logarithm of an array exponent. Okay, cool. These are the certain functions you will be using. There are other functions available as well. This is an array. We create a 1D array. What is the mean? Mean is average of everything. 3, 5, 4, 4 divided by whatever it is. Okay, let's not spend much time behind it. Minimum of all the array. Let's say in this array you can see 1. 1 is the minimum of the array and maximum is 33. So np.max to 30. Standard deviation between the elements is 12 point, okay, 10.16 something. The variances, okay, this is the variance. We already did sum, right? No, we did not. The sum is 57. Maybe we'll do sum, then we'll get to know. Product is multiplication of all the elements is 9. I don't think so. Oh, yeah, see? 1 lakh 9. Okay, 19,800. That is the product of all the elements. Yeah, there's no zero. Okay, let's do a zero just to check. It's zero. Get it? You want to get percentile of 50. Okay, what exactly is this percentile of 50? For the 15th percentile median. Okay. Compute the percentile of an array for the 50th percentile. Uh, it's something mathematical. Okay, let's try to understand it. Okay, percentile for the 50th percentile. Hmm. What could this be? Array percentile, 50th percentile is 2.5. Um, what we'll do? We will understand it together. Help me understand this. We call the values an array, sorts them, find the value that splits the data in half. 50% of the fall value is the this point and 50% above. So let's say this is NumPy and NumPy. In this case, in the middle, two value 1, 3, and the above is 7, 9. Oh, get it. So that is like 50% of the value where it falls. Okay, np dot median. So for this value is 50th percentile. Okay, that's the middle element, I believe. Okay, where the 50% of all the elements fall. If I do, okay, did you guys understand? There's an array. I want to find the 50th percentile, which is almost the median. So it will sort the array, split it into the half, and get me the 50th percentile. Let's say if I do a 25, now if I do 90, it should give me something above. I think if I check
Closer
here,
to last
it should
element.
be 16 point something something. Okay, it's at the higher end. Okay, if I go to 9, it will be 1. That will be top 10%. Let's say there are how many? 1, 2, 3, 4, 5, 6, 7, 8. So that is a 100 divided by 8, which is 16, and it gets the first element. That's something what I'm understanding. Okay. NP argmin of array. Okay. What does that mean? Now this time we'll check in the documentation.
It returns the
NP,
index, I guess, of
it
the.
is the what? Index of the minimum element, right? Krish, come again?
Yeah, yeah. I
Index
was
of the
saying
minimum element,
it
right?
returns the index. Yeah.
Yeah. That's true. So let's go here. Argmin of array. If I get an array, okay, index of the minimal element 1, 2, 3, 4, 5. Okay, 0, 1, 2, 3, 4, 5, which is the first element. Get it? Excellent. Okay, 5. Then I want index of the maximum element. It is argmax of array. Okay, that is 33. 0, 1, 2, 3. We got the maximum element. And I want to get list of all the unique. Okay. What is cumulative sum? I have no idea. I had idea of everything, but cumulative sum is I don't have any idea. So
It
what
is like
we'll do?
Fibonacci sequence. 1 plus 2 3, 2 plus 3, like something.
Okay, okay. Cool, cool, cool. So idea was to show how to use documentation, and
Uh,
thank you so much for your insight. Okay, NumPy cumulative sum. So when you do a cumulative sum, that is Fibonacci series, that is 1 of 3, 1 2 of 3 is 8, 1 3 of 5 is 10. This is okay. Hey, what's this? Okay, then we have one Fibonacci is n into n plus 1. Then we have 10, then that's 43, that's 45, 57. Okay, let's check here. D type. Okay, cumulative sum of A. What is A? Is an array. Then you do this. Okay, you get 1, 3, 4, 5, 6. So cumulative sum on a 2D array, how do I understand it? Krish, if you can help me understand.
let's see.
Okay, let's understand it together. Array, this is a 2D array, 1, 2, 3, 4, 5, 6. Then array, what I get is this. I want to do a cumulative sum on A. On
Okay, yeah.
modular,
So it's 1 plus 2, then
it's 1.
1 plus 2 plus 3, like row wise. If you go row wise, for first
Hmm.
1 plus 2 3, 1 plus 2 plus 3,
No, the
that's
first
6.
element is 1, right?
Yeah, the first one is only one. Then you
Hmm.
add the next two,
Then 1
the
plus
one
2
and
is
two.
3.
Yeah,
Get it?
and one plus
Then
two
I
plus
already have
three.
3. 3 plus 3 is 6.
No,
6
no,
plus
one
4,
plus two plus
10.
yeah, 6 plus 4.
Yeah,
Then
yeah, yeah.
one plus
1 plus
uh,
3 is 6 plus 4, 10. Then
10
10
plus
plus 5,
five,
15.
15, and
And 15 plus
and
6 is
6.
21. Okay. Okay. Get it? Is everybody clear?
Yes.
Okay, that's how you get it. So cumulative sum is Fibonacci series of a number. Not the sum, but Fibonacci sequence of a number. That is what I understand. Okay. Any doubt here? What I'll do, I'll share a PDF this time. Maybe I'll share it on WhatsApp. Just give me a minute. Do you want to do it? Class, do you want to go through it? Maybe write it down in your notebook.
We can skip it, I think. So we can
Yeah.
do it
Okay.
better if you share it.
I'll share the documentation. Just give me a
Yes.
minute. Document. Statement of language. Not able to find it. Hmm. Now I have it. Okay. We have handbook of everything. And this will have code, built-in mathematical function. Okay. Okay. Correlation coefficient, I don't remember. Chris, do you understand what it is?
Actually, I also forget
Even I forgot.
correlation
Okay,
and
let's skip it.
coefficient.
If going forward we have to use it, we will use. Okay, so these are the mathematical functions that we can use, and that is it. So we have finished our NumPy class, and today I'm extremely happy I was able to finish it. Usually, this is where we end the class with doing this stuff. Cool. We'll get started with Pandas. Anybody, any ideas what pandas is? If anybody can help me understand.
I think it is used to clean the data and the like import the files.
It is what?
It is used to clean the data and import the CSV files. We import
Uh,
it and we clean it.
not it's a use of pandas. Pandas are data frame. Similarly to arrays, pandas are more efficient. Okay, that's it. Pandas gives you a lot of inbuilt function, and you can do data manipulation. It's used for data cleaning. Importing files from CSV is one of the functionality that pandas allows. You can even import to Excel. So pandas does allow a lot of functionality out of it. So today we will get started with pandas. Give me a minute. Here we are. Okay. As mentioned, it is a Panda. There can be Panda series, Panda data frame. We will not go through the definition. What we will do, we will quickly start with our work. Okay. What is Pandas? Will not go through it. We'll start with how to use Pandas. Okay. Before starting, all I want to ask is everybody clear on NumPy? It is not something you learn by seeing. You have to practice it. Something even I forget if I don't do it for a month or so. Not month, maybe 6 so I forget it. And always try to use documentation. Let's say if you're stuck anywhere, use documentation. Keep asking questions like how it should be using. And while you're learning it, try different argument. Let's say if it is some, try something else. Maybe check what are the other arguments that you can pass through. So that will help you understand. So when you are working on a production-based database, production code, my bad, production code or production data, then this will be helpful. Okay, we will come with Panda. We'll get started with Panda. Okay, Panda is a built-in two main. There are two data structures, which is series and a data frame. Oh, my bad. Okay, series and a data frame. Okay, this is how you create a Panda series. Okay, which is a 1D array, a one-dimensional array, single column, which is called series. A two-dimensional array, it is a data frame. Usually, when there are Excel sheets and everything, you can, in order to manipulate, you can use Panda, as Devish mentioned, that importing file through CSV and manipulating them. Data cleaning, yeah, definitely, data cleaning is one of the things. Data analyzing, data visualizing, all of these are part of Panda. That will help you do that. Okay, this is how you create a PD series. Okay, there are no automatic index. In a series, you can manipulate the index. Okay, usually the index by default are 0, 1, 2, 3. You can set them to A, B, C. Okay, a Panda series may look to a Python dictionary because both store with data with label, but series offers much more. Like unlike a dictionary, a series supports fast vectorization operation, automatic index alignment during arithmetic, and handles missing data using NaN. Usually, all of these features are not available in Python. Not usually, definitely they are not available in Python. If there are empty array, empty data, it will not put data by itself. Okay, it also allows both label-based position and access. The accessing in pandas is more seamless. You can provide the indexing. Okay, while a dictionary is a far simple value storage, a series is a better suited for data analysis and manipulation tasks that corresponds flexibility to build method, a built-in functionality method. Now this is a 2D array. A 2D array or a data frame which is similar to a dictionary. Okay, let's say data name. Okay, there are certain elements. This is key. This is value. Think of this as a header, and these are all the values. Now, when you create a data frame, this is how it gets created. Okay, there are three elements: name, city, age, Alice, Bob, as you can see. It creates a 2D array. Okay, every series and data frame has an index. It helps in fast lookup, aligning data, merging and joining time, view relations. Okay. You want to get all the index, columns, values, everything. All of these are possible. Let's skim through it. While we are coding, we will be working on it on. Okay. Now, most pandas operation which we need is selection. Okay. Is select. What is it? Yeah, it's selection, filtering, merging, aggregation. You will understand going forward. Okay, remember a series is a 1D array with label, a data frame is a 2D array with rows and columns. Okay, as we imported NumPy, that was import NumPy is pandas as NP. Similarly, for pandas, it will be import pandas as PD. If you have Anaconda installed, pandas will be installed automatically. Okay, now I have created a series. This is a pd.series. 71 this these are the is the one day element. Now if you do a type, you will see it is of type series. If you print it, it is similar to a 1D array. Get it? 0, 1, 2, 3, 4, 5, 6 are the indexes. 78, these are the values. Now what I want to do, I want to change the index to these elements. Can I do it? Of course I can do it. This is not something you can do in Python, but you can do it. Now, Harry has 71. It is more like, let's say I'm creating a key value pair where Harry's value is 71, Shob is 84, John 80, 98, and so on. If I want to access the value of Harry, this is how I access it. That is 71. The value of Harry would be 71. As you can see, this is more of a like key value pair, a dictionary kind of a thing. But all of these are in a linear data structure. They are not in a key value pair. Okay, let's go. If I want to access Rohan's data, get it? Okay. I think it would be a bit overwhelming. I would like you to write it down till this in the notebook, and then we'll move on. Okay, let me know when done.
That,
Yeah, done, right? Everybody?
Yes.
Cool. Okay. Going forward, then we will come to data frame. Okay. A data frame is a 2D array. In most cases, we will be using data frame because that is my experience. Usually, let's say, so we can connect pandas to a database. We can connect it to a JSON. We can export a JSON to pandas. We can export a CSV to pandas, Excel file, and connect to database as well. So that is where data frame comes into picture. And this is how most data look. Let's say if you go into a database can have multiple rows and multiple columns. This is how you can visualize all the data that is available. Hardly there are 3D data. I mean, there are no 3D data available on let's say on a database. It's always 2D, which are row column value. And when and that's the difference between NumPy and Pandas. So in NumPy, you will have mathematical data that will be 3D, 4D, or whatever. That is used for visualization. If you want to create a model, if you want to create a visualization which is 3D, let's say if you want to draw an image and all that. So you need more details, you need more dimensions. But that where NumPy is coming to picture. Whereas Pandas is mostly for analyzing data. It's mostly how to filter your data, how to select your data, how to aggregate your data using data that are available in real world. So that is the difference. Now, if you can see, here is data frame. We created data frame from a dictionary. This is a dictionary key to an array value. There is a think of it as a column, and these are all the values. We have age, we have city, and this is one of the ways of creating data frame. This is not how you are going to do it. In most cases, either you are going to import it from the CSV or you will be directly connecting it with a database. That's how you're going to use it. So this is good to get started, and this is how you get the data frame. So this is how it is created. Now, if you create on index, you will see the start of the index is 0. It stops at 3, that is the last element, and the step is 1. So as you can 0, 1, 2, 3. And that's the reason that is the range of index that is being shown. If you want to check all the columns, you click on the columns, you get all the columns, name, age, city. This is a small data, so you may feel that these functions are not very useful, but these are very useful functions going forward. There are cases when, let's say, there are data is not available, so it could be 0, 5, 10, and all of this. So you will get an idea like what is the range of the index. Is there a step? Is there a skipping at any point? Then how many columns are available? You may not want to work on all the columns. You only need two columns, which is name and city or name and age. So by a click of by a function, you'll get all the details. Okay, I'll put it in the chat. You can copy paste and let me know when you are done. Okay. And while typing it out, if you have any questions, do let me know. I'll be happy to help. Is it done?
Yeah.
Nishan, done, right?
Yes, yes.
Any doubt, any confusion? Okay, cool. I've shared a CSV file, so maybe download it. In the meantime, let's go through it. Okay, let's get started. So here we have pandas. What we are going, we have a 2D array, and if you want to convert it into a data frame, that's how you do it. You provide the data, but the important part is you have to provide a column. What we'll do? Not go through it. Let's go through the code part. Okay, cool. I have everybody's attention, right? Okay, cool. This is a 2D array. If we go through our data, this is the 2D array that you created. Now, if I want to create a data frame out of it, this is how you create it. There's a data, then there's a column, and the columns are name and marks, which is irrespective of the index. Now, what if I remove the column? What if I just remove the column? Okay. What will happen? It will still work, but it will be 0 and 1. If you want to create a 2D array, sorry, a data frame out of 2D array, this is how you do it. Sorry, how you do it. And if you want to specify a specific column, you pass an argument, this column, names and mark or whatever would be your value. Now we have a key value pair. Okay, there's a key, there's an array. Okay. If you look at the data, this is how the data looks. 463, If you want to create a data frame, this will create. But since I already have a key, this key will transform into column. Can you see it? This has transformed into a column. A, B, 4, 5, 6, 0, 1, 2, 3. Get it? And now what we have, we are using NumPy. We're creating a 2D array. Okay, we have a 2D array, which is this. Then we are creating a data frame. Okay, now if I do a DS, how does it stand? Let's check. Column A, B. So this is A, this is B, this is A, this is B, and this will be 1, 5, and B will be 2, 6. Get it? What I'm trying to convey? Okay.
Yeah.
So you can even pass NumPy elements in a data frame. Now, if I want to, I don't have data.xls. So let's not. If you want to read Excel, this is the function you use. Very self-explanatory. Read Excel. We don't have it. I do have data.csv, but it is doing something. Hmm, it is from- hmm, In order to read CSV, you have to specify the path to the CSV file. And when I read it, and when I print it, I get this data frame. Okay. I have shared the CSV with you. We'll do data manipulation. If you want to read from a JSON, it is data.json. Similarly, JSON, you know what JSON is, right? It will be inside braces, certain elements, and this is how it would be able to render. You can directly render it from cloud. Let's say there is a CSV that is available on this particular location. What we'll do, we'll try to build. It does not have to be in your local. You can directly get CSV from from the cloud. Let's say this is hosted on GitHub. It is not in my system, but when I do it, I'm able to get all the details, able to fetch it. Okay. Similarly, head. Let's say if you run a head command, you'll get the top 5 elements of the data frame. That is 0, 5. If I want to do a head of let's say 15, can I do it? Definitely. I want to get the top 14 elements, so I pass a argument. But usually default is 5. If you want to get the last 5 elements, then you get tail. Okay. Now, if you want to get all the information what are present, that is df.info, dataframe.info, then you get it, like all the columns that are available. There are no null content. What are the data types, is an object data, is the data, how many matrices you. Then we have describe. Describe is something as you saw that in order to do certain operations on NumPy, we were doing count, mean, standard deviation. So this is the percentile that we were talking about. So all of that we have it here. You do a describe, you get the count, that is total bill, total bill price, the mean, the standard deviation, okay, for the total bill for the case and everything that we get it. Similarly, let's say there are, this is the all the columns that are available, and we have df.shape, the shape of the element. So there are total 7 columns and 244 rows, which are available on this particular data frame. Okay, we quickly went through it. We'll go through the documentation. Okay, we'll go through the documentation. Something that we missed is we can directly connect to a database, okay, and work on it. It could be any database, and you can do manipulation. You can do read SQL. Oh my God. Did you guys work on SQLite 3 by any chance? No, right? It's a file-based database. So it's something you can use it on your local system and work on it. Okay. I think we have covered everything. Okay, head, tail, info, describe, shape. Okay, let's write it down in the notebook. And while you're doing it, if you have any question, do let me know. Shall I scroll down?
Yeah, so
Is it done? Done, right? Yeah, let me know when you're done. Okay, don't read it from Excel file and don't read it from CSV. Let's not do it JSON. Head, tail, info, describe with something. Okay, do it from here. I'll share the URL. Because we will be doing all these operations. At least you are maybe. I've shared the link on the chat. Thank you.
Scroll up, like,
Yes, please.
can you scroll?
Oh, you want me to scroll? Okay. While you're writing, calling this function, maybe visualize, not visualize, but maybe just don't copy it. Also, like repeat it in your head, like it's head, like at the top element, tail, like at the bottom element, info, using all the information. That describes these all the mathematical combinations, columns, array, and shape information, and then the rows and columns, something like that. Let me know when done.
It is done from my side, and I think I will leave now. I have a few of the tasks to do.
Oh, okay, cool. Thank you, Chris. Thank you for your time. I'll shut it up.
I will just
Yeah,
go through the video.
Okay, okay, I'll definitely share. Okay, Nishant, Davis, let's continue to next lecture. Nishant, are you done?
yes, I'm done.
Okay, cool. So what we are going to do, we are going to check the filtering and selection which are available, which can be achieved using pandas, pandas, speaking pandas. Hmm. We'll go through it later. Let's go through the code first. Okay, it's pandas. I've shared the CSV. You can download it later, but let's not go through it. This is the CSV I'll be using. All the data. Okay. This is data of the actor, film, year, the genre, the box office collection, IMDb rating. Okay. Now I want to check the type of DF of actor. So data frame is made up of multiple series. So this is a series, this is a series, this is a series, this is a series. Okay. If you check actor, actor is a series. Okay. The type of actor data frame is a series like DF of actor. Now I want to only get fetch actor and IMDb. This is how you select the IMDb rating. You select them by column. Okay. Inside a data frame, you specify an array, and there you get a 2D column. So this will give you the actor and the IMDb rating. I don't want to work on all of it. I only want to work on two columns. Okay. Devesh, are you following? Cool, cool.
Yes,
I
sir, I'm
believe.
writing.
Yes, yes, yes. Maybe please do code. I mean, write it down when you have your laptop up and running.
Okay.
You should be doing it. Okay. Then we have df location of one. So if you check here, this is location of one. That is LOC of one. One. This is the value. If I want to get location of one value, then I am getting Salman Khan Tiger Zinda Hai year. That is, this is how you do it. Get it? Now there is I location of one. Now the difference between this is, let's say if I do a index location, then it will go through index. That is the first element. And if you do just location, it will fetch you by column. Let's say there are possibilities that after zero, there can be directly three. If you do df location of one, it will give the three element because these two are not present. If you can visualize it. But if you do I location of one, it will give an error because index location is not present of that element. So that's the difference. Okay. Now I want to only get IMDb's rating of the seventh location, is 6.5. So if I go to 0, 1, 2, 3, 4, 7, the IMDb rating is 6.5. This is how you do it. Okay. Similarly, index location of 7 of 5 is also will also work. Okay. This is 0, 1, 2, 3, 4, 5. Sorry, 0, 1, 2, 3, 4, 5. This is 5. This is also can work. Okay. If I'm going a bit fast, do let me know. I'll slow it down. DF of location, seventh element, which is Tiger Zinda Hai, and 5, that is fifth column. This is also you can do. Okay. This is also possible. Let's say that is DF location. You want to split it from 0 to 2, that is 0, 1, 2, and you want to get all the columns that are certain in this way. That also, this is how you do it. This is the level of selection. Then you only, or you can also do like 0, 1, 2 of the column, sorry, 0, 1, 2 of the row and 0, 1, 2 of column. Okay. This is also you can fetch it. Okay. Now you want to get the value. You want to fetch the value that is 0 of actor, you get Shah Rukh Khan. That is 0 of actor is Shah Rukh Khan. Okay. Now, if you want to check, whenever there is an I, think of it as an index. Okay. DF index 0, 0 is Shah Rukh Khan. Okay. The more you practice, the more you will understand. Like right now, you will just understand the syntax and what are the functionalities that we can achieve through Pandas. Then we have data frame. If data frame, this is the Boolean filtering that we also did in NumPy. Okay, that is data frame. If the data frame IMDb rating is greater than 6, then show all the elements. As you can see, all the IMDb rating is a greater than 6. Sometimes there will be certain challenge. Let's say if you're fetching data from the database and these are type string. So what you have to do, you have to convert them into integer or float, whatever the appropriate data type you think, and then you have to run filter. Also, you have to keep in mind, like if there are any Boolean decimal values available. If there's a decimal value available, it has to be a float data type. So all of this has to be kept in mind. Then we have another data frame that is this is the filtering. The IMDb rating should be greater than 6 or the year should be greater than 2018. So as you can see, the IMDb rating is 5.6, but the year is 2022, and hence the filtering works. Okay. You can also write a query. Okay. Similar. Okay. df.query. This is the column. This is case sensitive. If year is greater than 2016 and IMDb greater than, if you want to write it in a language, you use query. Okay. Then you print the data frame. Okay. Let's say if you want to create a similar to NumPy. Let's say if you want to create a copy. Usually when you do a reference, it will pass as a reference. But if you want to create a separate copy, use a copy function. That would be the better way to do it. Okay. Similarly, you get the location. Now I am manipulating the data frame. There is a data frame. I am changing it to Harry. Let's instead of Harry, let's put uh, okay. Okay. Oh, none of it is defined. So what I'll do, run all. Okay, you see the actor is Nishant now. See, that is the level of manipulation that we can do. Now, as you can see, df to change, but df did not change because we did a copy. It was not reference. Okay, and that is it. So what I'll do, I'll clear all of it. Maybe, and we will, no, before that, let's go through the documentation if you miss it. Okay, we did selecting on the column. If it is single column, this we can do it. If it's a data frame, this is a 2D way to do it. Okay, this is label RDF of location, that is by label, df of that is index. Okay, if you want to get specific rows, you can get uh, specific row. Where do you go? Hmm. You can get it by name. If you want it through index, then you have to use I location. Slicing, the level of slicing that we can achieve, how we can do slicing. We can slice it on the column level. We can pass the name. We can also pass the entry key. Always remember, if you want to do it on a label base, it is location. If you want to do it on index base, it is I location. Okay. If you want to fetch the value, then this is how you can fetch the value. If you want to fetch the value through index, that is IAT. Okay. This is the level of filtering that we can do. Then there are multiple conditions. And we went through all of it, all of it, all of it. Cool. Logical operators, we can achieve logical operators, so we can pass through it. Cool. Okay. While you go through it, you would be able to come through query and let me know. So what I'll do, I'll just keep it right here. And after you are done copying it in your notebook, and if you have any doubt, do let me know. You have the CSV, right? I've shared it over WhatsApp.
Yeah, we pasted.
Okay. Maybe let's get started with that. Let me know when done. Are you able to import the CSV, Nishan?
Yes,
Oh, cool, cool, cool. There are series and data frame. Series is a 1D array. Data frame is a 2D array. In most cases, we will be using data frame because that is how data are stored, be it any data array. For mathematical operations and everything, NumPy. So let's scroll down.
Yeah,
Only you are doing it, Nishan. Devesh don't have laptop. So as soon as you are done, let me know. And any doubt, just you can quickly ask me.
yeah,
Stand, right? BFI location 7th row, 5th column. If you want to split on location, then 0, 3. Thank you. Any doubt anywhere, do let me know. Conditional filtering is something we'll be using a lot. That something is being used. Mm, so to understand what is the type of the data, quality of the data. So to form a logic where we can understand how we should filter it. Mhm. Any doubt anyway, do let me know.
Done.
And now this is okay. Understand copy, understand query. We're doing the same thing, but this is well written. It's more readable. And I personally prefer this than this. Done, right? Cool. Awesome. Okay. Any doubt anywhere? All right. Okay. So today I am extremely happy I was able to complete whatever I planned for. We finished NumPy, we finished Pandas. We'll continue in the next lecture. We will get started with Pandas and we will hopefully finish Pandas in the next. Okay. Thank you, everyone. Thank you so much for your time. And if you have any concern or any query, do let me know. I'll be happy to help. Okay. See you. See you next time.